Hi guys, today we are going to be talking about functions. So we're going to do a little bit of an introduction. So we're going to call it understanding functions. So the definition of a function is a relation where every input has only one output. Okay, so you're going to need to know this definition for this entire unit. So a function is a relation where every input, or x is the input, has only one output, or one y. Okay, so let's look at that in terms of a graph, what we are talking about. Okay, so just in like regular terms, when you're thinking of a function, I like to have my students think of a vending machine. So a vending machine, say it's a soda machine. If you push the Sprite button, every time you push the Sprite button, you get a Sprite. If it does that, every time you push the Coke button, you get a Coke. Think of that as a function. So we're going to be talking about a function machine. You're going to think of a soda machine, okay? And then if every time you push the Coke button, you get a Coke, and every time you push the Sprite button, you get a Sprite, then it's functioning. It is a function, okay? What happens if you push the Sprite button? So I put in my money, I push the Sprite, and I get a Sprite the first time. But then I go back and I want to get one for my friend. And I push the Sprite button and I get a Coke. That vending machine is not functioning correctly, right? I pushed the Sprite button and one time I got a Sprite and one time I got a Coke. So each input doesn't have only one output, okay? I'm getting two different outputs. Sometimes I'm getting a Sprite and sometimes I'm getting a Coke. So every time we push the button, we should get the same thing, no matter what. And so on the graph, what that looks like is each x has only one y. So something like this is a graph. When x is -5, y is this value. When x is 3, it's this value. When x is 0, it's this value, okay? Each x has only one y. Same thing with this kind of graph. Okay, there's only one y value for each x value. Each x has exactly one y. Okay, compare that with a non-function. We turn our graph this way. When x is 0, y is, say, 3, -½ and -3. See how I got 3 different y's? That's why it's not a function. I pushed the Sprite button, and once I got a Sprite, once I got a Coke, and once I got a Diet Coke. Okay, so That makes it not a function. Same thing if we have something like this. So when x is, let's say, -2 over here, I have all kinds of different outputs, right? I have Sprite, a Coke, a Dr. Pepper, a Mountain Dew, a Gatorade, and a water. Okay, I got all these different outputs. So that's why this one is not a function. Okay, so when we're talking about graphs, we can use what's called the vertical line test. And this says, if a vertical line intersects the graph more than once, it is not a function. So we can use that up here in these graphs that we drew. So anywhere we draw a vertical line or we move our pen, each of these it only crosses one time. However, if we take our pen and we slide it across the non-function graph, you'll notice in this first one, almost everywhere it crosses 3 different times. That's why it's not a function. In this one, it's good for most of it, but when you get right here, see it crosses multiple times? That means it is not a function. That means this x value has multiple y values, a bunch of different outputs, which makes it not a function. Okay, so we're going to also look at tables. And when you look at a table, each input can only have one output. Okay, so let's look at our table here. So x, remember that's our input, and y is our output. So does each input have only one output? Well, all we're worried about are ones that repeat. So if we look at 1, 3, and then this one also has an x of 1, look, we get a 2. So this is not a function. The input 1 has 2 different outputs. Right? One time we pushed the 1 and we got a 3. One time we pushed the 1 and we got a 2. So it's not predictable. It's not functioning. It's not a function. Okay? It's not consistent. Let's look at one that is a function. So looking at this table, -5 and 5 repeat themselves several times. So we have -5, -5, -5, 5, 5, 5. Okay, which is fine. The x's can repeat themselves as long as the y's are the same every single time. So let's look at all the -5s. Every time the x is -5, the y has to be 1. -5 and 1, -5 and 1. Okay, so the -5s are fine. Every single time we got the same output. Let's look at the +5s. -2, +5, -2, +5, and -2. Every input has only one output. Anytime you put in -5, you're going to get a +1. Anytime you put in a +5, you get a -2. So this one is a function. Every input has only one output. Okay, you might also see it like this too. So we have two groups. We have our x, we have our y. So if our input is -3, our output is 2. If our input is 2, our output is 3. If our input is 1, our output is 1. If our input is 5, our output is 4. Is this one a function? Yes. Every input has only one output. Let's do another one. So -3 goes to -2, -2 goes to 3, but 2 also goes to 4, and 1 goes to 1, and 5 goes to 1 as well. So it's fine for both of them to have the same output. What's not okay is the same input with two different outputs. So sometimes when you put in 2, you got a 3, and sometimes when you put in 2, you got a 4. So this one is not a function. So 2 has two different outputs. Right? You get 2 and 3, and then sometimes when you get 2, you get a 4. Okay, so you can't have this input has two different outputs, which is why it's not a function. Okay, and you're going to be using this for several of your assignments this unit. Let's look at your assignment today, which is understanding functions. So like we talked about a machine, every time you input it, it does something to it, the same thing over and over again, and it gives you the output. Okay, so we want to figure out the function rule, and we want to complete the table using that function rule. So if our input is 4, what's the machine doing when it spits out a 9? Well, adding 5, right? 4 plus 5 is 9. If you put in a 7 and you add 5, you get 12. If you have 3.5 and you put in 5, you get 8.5. And then you can complete the table, so you could say 1. If I put in 1 and I have to add 5, because that's the rule, I'm going to get 6. If I put in 10 and I add 5, my output would be 15. So my function rule is add 5. Okay, it doesn't always have to be numbers, kind of like we talked about a soda machine, or it can be words. So anytime the input is cat, you get a 1. Anytime it's house, you get a 3. Anytime you get a 2. So you could do cat again as long as your output is 1. And you can put house as long as your output is 3. Okay, so you're going to go ahead and finish these tables.